Hello, good evening, sir. Ambeth, sir. Shall we start the session, sir?
Yes, ma'am. Yes, ma'am.
Ambeth, sir. Good evening, sir.
Good evening, ma'am. Good evening, ma'am.
Yes, good evening to all. And it is my immense pleasure to welcome you all to the fifth day of the AICT sponsored ATAL 6-day online faculty development program on transforming industries with AI, deep learning breakthroughs, and real world applications, organized by Department of Computer Science Engineering of Mizoram Institute of Science and Technology, Ramapuram, Chennai. It is my privilege to welcome our esteemed resource person for the day 5, session 9 of this faculty development program, Dr. V.D. Ambeth Kumar. We are honored to introduce Dr. V.D. Ambeth Kumar, an associate professor at Mizoram University, India. Mr. V.D. Ambeth Kumar received PhD in Computer Science Engineering from Satyabama University in the year 2013. He pursued his BE Computer Science Engineering from Annamalai University and BE Computer Science Engineering from Madurai Kamaraj University in the year 2006 and 2004. He has a rich experience in the field of computer science and engineering close to a decade. Dr. V.D. Ambeth Kumar has contributed in technology initiatives and published books on theory of computation, design and analysis of algorithm, Python programming, and advanced computer architectures. His articles are published in 88 international journals, 6 in national journals. He has presented papers in more than 60 national and international conferences. Mr. V.D. Ambeth Kumar is a recognized supervisor of Anna University and he is guiding research scholars for PhD program. He is a recipient of Best Teacher Award in the year 2011 and he has 15 copyrights and 5 patents. His work has been profiled broadly in image processing, pattern recognition, neural networks, and networking. His research interests include computational model, compiler design, data structure, and microprocessor. Dr. V.D. Ambeth Kumar is a reviewer and editor of many reputed journals, and he is life member of IEEE, ISTE, IA-Inch, and ICEEE. Kindly join me in extending a warm welcome to Dr. V.D. Ambeth Kumar sir to our faculty development program and invite him to share his insights and inspire with his words. Welcome you, sir.
Thank you, ma'am. Thank you for inviting me. Ma'am, can I share my screen, ma'am?
Sure. Yes, sir. Wait a minute. Now you can share your screen, sir.
Yes, ma'am. My screen is visible, ma'am?
Yes, sir. Yes.
Yes. Good morning to everyone. So myself, Dr. V.D. Ambeth Kumar. Already ma'am is introduced about myself. So today my topic is AI applications in agriculture for the crop health monitoring and precision farming and yield protection, right? This is my topic. So everyone know all the field right now AI is involved more, right? So how they AI to involve with agriculture field. This is my topic today, right? So mainly focus on the crop health monitoring, right? So before that, so today I delivered the content is first, what is the crop monitoring? And next, what do you mean by precision farming and crop monitoring? What is the difference between these two, right? Next, in the agriculture field, how the deep learning do involve, not only deep learning, AI how to involve with this agriculture field, right? That manner only I explained next session, right? So what do you mean by crop monitoring? Right. What do you mean by crop monitoring and precision framing? Precision framing is nothing but continuous observation and assessment of the crops during the growth cycle, full cycle, right? So this is called as a precision farming. And crop monitoring is nothing but a data-driven approach, the agriculture that uses the advanced technology like GPS or IoT or AI technology, how they optimize resource usage. In this is called as a crop monitoring. So what do you mean by smart farming? Smart farming is nothing but this precision farming and the crop monitoring combined together, it is getting for the smart farming. What is the benefit for the, that's fine, once again, sorry, right. So this is called as a precision farming and crop monitoring, and the smart farming is nothing but is a combined the precision farming and crop monitoring, that is called as a smart farming. So what is the benefit for the precision farming? So we know continuous, already I explained, precision farming is nothing but continuous observation and assessment for the crop, the yielding time, and crop monitoring nothing but using the technology, how they monitoring for the crops, right? So what is the benefit for the precision farming means, obviously continually you monitor for the crop yield means automatically increasing the farming yield. And suppose in the crops have some disease also there, easily we predicate our quick response or decision making by the farmer, that is called as a advantage for the precision farming and crop monitoring. Another one is you are using suppose a recommendation. So based on the crop recommendation, generally crop recommendation, what are the feature? Environment factor is the important feature. So we based on the soil type and soil pH value and the nutrition of the soil and soil moisture, soil temperature. Based on this, the crop will be recommended, right? So then weather, based on the weather also. For example, temperature, rainfall, humidity, and so these are the factors, right? And location also, which location the crop will be yield. So these are the factors important for the crop recommendation, right? So in the benefits, precision framing, main benefits for the precision framing and crop monitoring are means easily you find out the disease production and increase the farming, our farming yielding. So many factors, right? This is advantage for the precision farming, right? Right. So I will come to the directly for the point. So my topic is a crop recommendation, right? So generally in the agriculture project, not only agriculture project, all the project for whatever medical application or any application through AI. So these are the important flow structure, right? So first, the data collection is very, very important. Generally, any machine learning project or deep learning project, the data collection is very, very important. So first, where we collect from the data and how to collect from the data, that is important. Next, after collecting the data, how we import to our data to our model. And next, after collecting the data, after we import the data, we do for the data pre-processing. So data pre-processing, what do you mean by pre-processing? Pre-processing means before the processing we do something, right? That is called as a pre-processing. Here data pre-processing, suppose first I will explain the data clearly. In the data, generally data in agriculture field, data, they have the two kind of data. One is the CSV file data or image file data. In the CSV file data, right, in the crop recommendation, for example, crop recommendation. In the crop recommendation, what are the features? Generally, we suppose we are collecting from the data some Google or some agriculture ICOR research center or something, some GitHub also. We collect the data. The data should be sometimes CSV file. The data should be sometime image file, right? Suppose we are using the CSV file means what are the in the crop recommendation system, what are the factors also there? One is the environment factor, important factors, and weather and climate factors, and location based factors. These are the main factors in the CSV file, right? You just open the CSV file. Generally, in the crop recommendation system, soil type, soil pH value, soil nutrition, soil moisture and temperature and rainfall, humidity. These are the factors is available in the CSV file, right? So you first look all the features, analyze, right? That feature is it's important for your crop recommendation or not. If some features is does not need, you just omit the features, right? Suppose if that feature is important but the data is not there, means how you manipulate the data, that is called as a data pre-processing. After data pre-processing, you analyze the data. So for example, which data in, for example, your CSV file have so many features out there. So from the features, 30 feature is important or 10 features is not required for this recommendation system. So you just omit it, right? That is called as a data analysis. So data analysis means you analyze what are the input, what is your output, what is your target, from the input, how we do. That is called as a data analysis, right? Next, you know already, because everyone, the faculty, everyone know. So in the ML model or DL model, we need the training and testing data. So obviously you divide 80 or 20% or 70 or 30% as per your wish, right? So you divide the training and testing data. After the training data, you build the model, ML model or DL model. After that, using the test data to evaluate our model is running is properly or not, right? That is generally agriculture field project everyone do. This is a flow structure for the agriculture, right? So next, I already explained. So in the data part is very, very important, where we collect the data, how we collect the data, right? And generally where we collect the data. So as a researcher, first we collect the data from the Haggle. Everyone searching in the Google, we search it automatically. Some researcher put in the data set in the Haggle, we download it directly, right? And sometime some repository is there, some foreign repository also there. So you collect from the data from the repository, or otherwise we collect the data set from the Google, or otherwise we collect the data set from the Agriculture Research Center. Generally, Agriculture Research Center, no one give the data. You formally request to the director for the Agriculture Research Center. Obviously, they accept your request. They send to the data to you. In machine learning repository, I'm telling, not only this repository, many repositories there. That repository also sometime open source also there, not open source also there. You suppose if you not give the open source, you recommend to just request to the concerned director, they will give to you. Okay, that manner we collect the data. So after collect the data, so the data, you download the data from these all the 4 factors. Gaggle you collect, or repository, or Google, or some Agriculture Research Center, you collect the data from these 4. After you collect the data, you stored in your drive. That drive is after you save your data in your drive, after that you open your Colab or TensorFlow, you upload the data to your drive to that Google, right? Your software. Otherwise, directly in, suppose your Kaggle, the data set is very huge. So what we do, directly that data will load to the your repository, right? From the data to that repository also sometime, right? From the repository to directly data copy, or otherwise upload the data, right? So these are the, so you know, in AI model or DL model, what some libraries are required. So you upload all the library. After that, you do for the data pre-processing. Already I explained the data pre-processing, right? So the 2 kind of data pre-processing. One is CSV file, have some data pre-processing, and the image file have some data pre-processing. So for example, your data have CSV file. First you analyze the data, what all the data, what are the feature is important to your research. First you analyze. After all the data is present or not, first you check it. All the data is present, it's okay, good. If not present, how you do imputation. Imputation means you do update the data, right, as per your mathematical calculation. And some data is not record, some features is not record means you dropping, just drop that features, right? That manner you do in the CSV file. Suppose your data have image, because my topic is crop disease prediction, right? Disease prediction is my topic today. So suppose that I take some image, right? That image have so many for example, in the image so many images there, so some unwanted image also there. So what I will do, so first I remove unwanted images, that after that whatever image is there, I proceed that image. So first I will check the quality of the image. That image quality is good, it's okay. If that image is quality is not good, so I will do some pre-processing. So what kind of pre-processing we do depends on the problem. So for example, our image is good quality, but edges is not good. So I will go for the contrast enhancement. Suppose corner only, right? Suppose I will go for some thresholding technique, some transform technique, sometime filtering technique. This is so many image pre-processing techniques there. So as per our problem, as per our input, what is the record for my problem, I will take that one, right? Okay, that manner I will do it, right? So okay, dropping after that, right? So this is a crop health monitoring system in using AI. So I will take two leaf. One leaf is a full green full. Here some yellow color. That yellow color should be sometime. This is for disease. Sometimes this is not disease also, right? This is a character of the leaf. Sometimes, right? We don't know, right? So this is, I will take this two example. It's a healthy issue leaf and a non-healthy leaf, right? So suppose I will already I explained here, after the data, after the do the pre-processing, after the data analysis, after splitting the data, and I will go for the machine learning model or DL model. Suppose I am using DL model. Suppose I am using the DL model. This leaf I directly upload to the our DL model. DL model based on the this pixel variation, they predict the good leaf or bad. How can telling not bad leaf? It's a disease prediction leaf. That manner they predict, right? This is happen or not. Suppose I am using the machine learning model, I will send to this leaf is not good. So before that, I will extract some features, right? That feature I will send to the machine learning model is good. For example, in the DL model, suppose I am create the DL model, I upload this leaf also, but I will go for the ML model. I'm not upload this leaf directly. So I will do some segmentation or some pre-processing technique, then I will upload to the machine learning model is good, right? So how I will do here, I will go for the segmentation technique. Why? Here the leaf have some disease also there, some different color also there. So first I will segment this leaf, this portion. After this portion, I extract some feature. That feature is mapped with our existing feature or not. That manner I will predict, right? That's why I will go for the segmentation. So segmentation have two kind of segmentation, right? One is a discontinuity segmentation and similarity based segmentation. What do you mean by discontinuity? Discontinuity is nothing but appropriate changes in the intensity level. For example, I will take this leaf. So here any changes, so it's nothing changes. Here full green color, here light green color, right? This is a changes, right? Appropriate changes means, for example, here leaf light green, here yellow. Appropriate changes here, right? Green to yellow. This is called as discontinuity method, right? And similarity method means it's partition of the image based on the predefined criteria, right? So for example, here green, here green, here green, here yellow, based on the previous pixel value, because here pixel value some values, here pixel value is similarly equal, here pixel value is similarly equal. I will come to this yellow, totally the pixel value is different. That manner we go for we will go means that is called as a similarity method, right? So in the similarity method, three kind of technique is there. One is a region proving and region splitting and thresholding, right? So here I will explain for the similarity method. In the similarity method, this is a mathematical formula for the similarity method. Max of g of x comma y. You know, all the image is represent for f of x comma y, right? Y, that is called as 2D image, right? So image means it's a f of x comma y as g of x comma y. This is a 2D representation. That's why maximum of g of x comma y and minus minimum of g of x comma y less than or equal to threshold. So this is a mathematical formula for the region splitting. The threshold is a user defined. As per our requirement, we change this threshold value, right? Okay. So here in the region splitting method, first I will take this leaf image or any image, I will take it. After that image, we convert to, you know, in as per the human visual, this is the image, but in the computer, it is a matrix, right? So so this image is not converted in the computer, it is a mathematical representation, it is a matrix representation. So this is, you just assume this is for the leaf image. Okay, that manner you assume it, right? That is called as a image. For the leaf image is equivalent for the matrix intensity for the leaf image, right? After getting that image, right, I divide the equal part. So here the matrix is a 8x8 matrix for that leaf. So I divide 4 quadrants, right? After the 4 quadrants, I will assume some threshold value. So here I am using t equal to 3. So here I am using t equal to 3. Sometimes somebody asking why you are choosing for threshold 3. So first I will choose initially 3. I will do the that segmentation process. After I am getting the exact output, whatever I am aiming the target is achieved, it's good. Suppose I didn't get, I will change my threshold until I reach my final answer, right? That manner we do it, right? Here I am assuming my threshold value is 3, right? So next, I will go for the segmentation. How we go? So you know already I told this is a formula for the region splitting. G of x comma maximum of g of x comma y, right? So and minus minimum of g of x comma y. So here after the 4 quadrant, so this 4 quadrants, what is this quadrants? This R1 quadrants I will take. What is the maximum value for this R1 quadrants? Here 7, right? Everyone follow? Okay, good. So maximum of this R1 region, what is the maximum value here? 7. What is the minimum value here? I think 4. So 7 minus 4, because I am using this formula. So maximum is 7, minimum is 4. 7 minus 4, I think 3, right? Yes. So 7 minus 4, I fixed my threshold value is 3. So 3. So obviously 3 equal less than or equal to 3 is condition is true, right? If it is true, right? So if this mathematical formula calculation is true, I have no need for the splitting. So there is no need for the splitting, right? So you check here, I am not due for the splitting. Here, no need for the splitting. Again, I will go for here. So what is the maximum value? Here 7. What is the minimum value? 2, right? So 7 minus 2. So 7 minus 2, 5. So our threshold value is 3. So 5 less than or equal to 3, condition is false. If it is false, it's record for the splitting, right? So I will go split again equally. Okay, so I will take this region. So this region, I think maximum values 3 and minimum value is 0, right? So 3 minus 0 obviously is 3. So 3 less than or equal to 3. So condition is true. True means there is no need. Here, no need for the splitting. Here, no need for the splitting. But here, record for the splitting. Here you check. What is the maximum? 7. What is the minimum? 2. So obviously 5. 5 less than or equal to 3. Condition is false. It go for the splitting. So you go for the splitting. Here I will take this region, right? This region, I underline this region, right? So here I will take maximum 7 and minimum 5. 7 minus 5, 2. And 2 less than or equal to 3 is condition is, I think, true, right? If it is true, again go for the splitting, right? So one second. Sorry. So here there is record for the splitting. Here I will check maximum 7 and minimum 4 and 3. It's also records the split. Here I think 5 minus 2, 3. It's record for splitting. Here I will do 7 minus 4, 3. It's record to split. That manner we go, right? So one second. So obviously, you hold this image. First, I will divide the 4 equivalent. There is apply for that formula. In the formula, there is no need for splitting here. Here, the splitting is record. Here, there is no need for splitting. Here, the splitting is record. So this is R1 region. This is R2 region. This is R3 region. This is R4 region, right? So R3 and R4 region, right? Here I will divide this region for R21, 22, 23. Likewise, you are using. Again, here we are using splitting. Here also record the splitting. Here also record the splitting. That manner we go. So until this condition is false. That is called as a region splitting, right? Okay. So after region splitting, so there is no doubt for the region splitting, right? So after region splitting, so you go for the region merging. So merging, how they do this R1 region and this region, not complete this region, right? It record for the merge or not. Here I will take same formula I can use because this is a standard mathematical formula. Maximum of g of x comma y minus minimum of g of x comma y less than equal to threshold value, right? So here, how we are do here, what is the maximum value here? 7. Minimum value taking from this region, not this region, right? So for example, R1 region and R2, 1, I will try to merge these two region, means maximum value I taken from this region and the minimum value I taken from this region. So here you check what is the maximum value here? 7. What is this region? What is the minimum value here? 5. So here 7 is there, here 5 is there. I subtract these two. What is 7 minus 2? Obviously 2. 2 less than or equal to your threshold value is no, you know, 3. So condition is obviously true. Okay, this condition is true. Again, vice versa, I will check. Here, what is the maximum value here? Maximum value R21 is 7. What is the minimum value here in R1 region? I think 4, right? So 7 minus 4, 3. 3 less than or equal to 3 condition is true. If it is true, both condition is true, you merge these true region. You understand when we try to merge? So as per the formula, you working both sides, right? Vice versa. Maximum g of x comma y minus minimum of g of x comma y less than or equal to threshold. That manner you merge vice versa, you check two region. This condition both are same for the two vice versa, then you merge with the two region. So now this R1 is merged with R21, right? Again, you go for the next, this two region is combined. It's now it is called as R1 region. Next, this R1 region, you compare with, for example, R22 region, you take it, right? If it is possible to merge or not. You take from the R1 region maximum and R2 from the minimum, you subtract, you compare the threshold value, it is true. Again, you vice versa, you check, both condition is true, you merge to these two region. If condition any one vice versa is not satisfied, means you will not to make with the merge with the two region, right? That manner you go. For example, likewise, I will go here, you check here merge record, here merge record. That manner you go. Here I will calculate the mathematically as per the formula. Finally, I segmented this portion. So this manner I will go means automatically that yellow color part. You understand? This yellow color part, easily you extract this portion. After this extract this portion, then you send to your ML model. ML will predict this is happen or not. You understand what I'm telling? Suppose in the ML model, you send these whole input to your ML model. Disease prediction a little bit difficult. Difficult means you are not getting good accuracy. Suppose you detect this portion, then send to your ML model, then the detection is get. That means the accuracy will get more. That's why I'm telling. Suppose you are using DL model, no need for this segmentation. Directly these two image you upload to the your DL model. DL model based on the similarity, they detect everything. But you using the, because here topic is AI. So in the AI model, not extract the feature. So in the DL model, there is no need for any feature extraction, no do for any segmentation, no do for the any pre-processing. You will directly upload, they easily they find. But in the ML model, so you do the pre-processing, after that you upload the data, it's good. Otherwise you do for the some segmentation process, after that you upload it, you are getting the accuracy will improve, some better accuracy you will get, right? So that manner we go. For example, this is I am telling. So first I will take the image, after that 4 quadrant, after that 4 quadrant, right? After that 4 quadrant, that manner you go. So obviously this edge will be you detected, this edge will be you detected. So next you upload to the your ML model, easily you find out that this is happen or not, right? That manner we go, right? So this is I'm telling. So everyone should understand what I'm telling. So once again I will tell, generally in the agriculture project, so data is very, very important, because without data we didn't do anything. So data we are getting from the Haggle. Generally everyone as a researcher we are getting from the Haggle, but sometimes the Haggle data is not good. So you directly approach to some research center is good, agriculture research center is good. So after you are getting the data, already I explained the data have the two kind of data in the agriculture field. One is a CSV file, another one is image file. In the CSV file means generally in the crop recommendation, disease prediction, obviously image only everyone use, not CSV file. But in the yield prediction and crop recommendation, in this two agriculture problem, generally everyone we are using the CSV file only. In the CSV file, you just download the CSV from the Google, you open the CSV file. Generally these feature only there. One is a soil type, what is the soil pH, and what is the NPK values, and the moisture and temperature, rainfall is humidity, longitude. So these are the feature generally is available in the CSV file. So after that CSV file, all the data is you do for the pre-processing. So pre-processing, two kind of pre-processing. One is a image have different kind of pre-processing, and CSV will have different kind of pre-processing. Suppose first you in the pre-processing, all the features is present or not. First you check. If not present, you some immutation you will do, right? Suppose the data is not important, you just omit it, drop it, right? This is a pre-processing in the CSV file. In image have edge segmentation, unfiltering, and contrast stretching, thresholding, and histogram. So many pre-processing is that you apply for any pre-processing, depends on the your research you will apply. After you apply, you analyze the data. So what is your input, what is your target, what that manner you analyze it. After analyze from the input data, you splitted the training and testing purpose. After the splitting, by using of the training data, you build the model, any model. So after building the model, to evaluate the data by using of the test, right? That manner we go. So next I will tell two important points in the data set, in the disease prediction. In the disease prediction, whatever data set you download from the Haggle, or you are collect from the any research center or repository, you suppose you are making the DL model, you upload your data directly, no problem. You making that how many layers you are used, a convolution layer or any general neural network also you can use it, no problem. So you upload that data directly your that neural network, they automatically they predict. But general multi-layer perceptron general neural network, you extract the feature, then upload is good. But convolution layer, obviously they predict as per the similarity, they predict everything, right? So in the suppose in the DL model, we need high configuration of the system. So that time you have, suppose you are using a large number of data, how we are proceed with your DL model? It's a very little bit difficult, right? That's why we go for the ML model. In the ML model, you before that you do for some pre-processing or some segmentation technique. Segmentation technique here I am using for some feature extraction purpose. So after extract the data, or here I am extracting color component data. After extracting the data, you upload the ML model, you do it, right? So here I am doing for this segmentation technique. After the segmentation technique, we upload our ML model, we are getting good accuracy, right? For the disease prediction, right? That's all in my side. If any doubt. Any doubt? Anything? Any queries?
Dear participants, you are welcome to ask questions to Dr. Ambeth Master. So the session is up to 7:30, sir. Suppose you have any more to add, you can also add.
Okay, ma'am. Okay, ma'am.
Good evening, sir.
Yes, ma'am.
If the I have one doubt. if the plant, suppose it have a two different disease means, how could I apply the single, can I apply the single model to identify, sir?
For the two different kind of disease occur in the same leaf.
Yes.
Yes, ma'am. Yes, ma'am. That's why I'm. But generally, in the DL model, does not know predict for the what kind of disease, right? They telling two different similarity is there. They predict. So after that, you are analyze what kind of, ma'am. I think one advice before your disease prediction, first what kind of disease is there. So what is the characteristics of that disease? First, you understand. Then after you uploading the data, they predict the model. That model they tell to the two kind of disease name they didn't tell, but they telling different two kind of this there. But after that you analyze this is this kind of disease.
Okay, sir. Thank you, sir.
Dear participants, you are welcome to ask questions to Ambeth sir. Any questions from participants? Any more questions from participants? The round participant, it posted the question in the chat box. The vision transformer can be used for disease detection, sir.
Sir, I have a question.
It is yes, ma'am. Tell me, ma'am.
Yes, sir. Can this model be applied on genomic data from NCBI?
Yes, ma'am. Yes, ma'am. Sure.
I see.
And vision transform also it's possible, right? I think somebody message to chat box. The vision transform can be used in the disease detection. Yes, it's possible, right? So based on the efficient of the features and global attention of the mechanism, so these are the factors. It is possible vision transform.
Any questions from participants?
Yes, somebody putting share the code, but I didn't never show the code. Okay, I will share the code, ma'am. Complete agriculture code I will share. But here, ma'am, one advice to everyone. Generally, code have whatever we need code we are collecting from the internet. They already have, right? But the concept is very, very important. How the segmentation is done. That is very, very important. After that, that segment based on the segmentation, theoretically you try to implement the code. That is good.
Sir, good evening, sir.
My code. Yes, ma'am.
Sir, do you have any idea about plant phenotyping and genotyping? Nowadays, we are seeing the papers like phenotyping and genotyping in plant agriculture.
Agriculture, yes, ma'am.
Yes, do you have? Actually, I know I have no idea about that, sir. what is phenotyping, what is genotyping. Nowadays, the people, if you're looking for agriculture paper, mostly the people were concentrating on that.
Yes, ma'am. Ma'am, I share my well, right now I completed one because I got one project in the agriculture only. Right now, this is second year I am going doing. I will send one data, ma'am. I data my document. That is help to you.
Thank you, sir. Thank you.
Sure, ma'am. I will share to you separately.
Any questions from participants, or shall we conclude this session? Any questions? Shall we conclude this session?
Ma'am, one participant posted the question in the chat box, ma'am.
Oh, okay.
1 second, ma'am. Data view. Yes. Who, ma'am? The author is I plan decision deduction real-time scenario such as varying the light condition is. Yes, of course, right? Light condition and leaf rotation is different, right? For example, varying light condition. If for example, you go for the some data augmentation, right? So including the image, varied lighting condition during the training. For example, we are taking the data, capture the data from the morning time, early morning time, or evening time. So so that manner we go means you are making some more data augmentation. You do for some pre-processing, especially in this condition we are using the histogram equalization is good for that lighting condition, right? Then you apply for that CNN model, it's good. Is interested multi data? Can you please share if any? Yes, who is the Biswas? 1 second, Biswas sir. 1 second. I will share my mail ID. Yes, sir. You just request data. I will share to you, sir. This is my mail ID.
Okay, sir. Thank you very much.
Yes, ma'am. Yes.
Any questions from participant?
I think no question.
Okay,
Ma'am,
yes.
once again, I thanks to SRM University, special ma'am Sudha ma'am and Sendil Selvi ma'am, right, to invite to me. Okay, ma'am. Thank you, ma'am.
Hello, we come to the end of day 5, session 9 of this faculty development program. On behalf of Department of Computer Science Engineering, SRM Institute of Science and Technology, Ramapuram, and the organizing team of AICT sponsor ATAL 6-day online faculty development program on transforming industries with AI, deep learning breakthroughs, and real-world application. It is my privilege to extend a heartfelt thanks to our distinguished speaker of this session, Dr. V.D. Ambeth Kumar. Your insightful session on AI applications in agriculture for crop health monitoring, precision farming, and yield prediction using deep learning has significantly enriched our understanding of the transformative potential of AI in the agricultural sector, sir. The depth of the knowledge and practical perspective we shared have provided our participants with a comprehensive view of how the AI can be harnessed to address real-world challenges in agricultural fields. Sir. We deeply appreciate the time and effort you dedicated for preparing and delivering an engaging and informative session. Your expertise has not only enlightened our participants but also inspired them to explore and integrate AI-driven solutions in their respective fields. Thank you once again, sir, for graciously accepting your invitation and sharing your valuable time and expertise, which greatly contributed to the success of our faculty development program. We look forward to future opportunities to collaborate and gain insight from your vast experience, sir. I also extend my gratitude to all the participants for their involvement and supporting for making this session a success. Thank you, sir. And all the participants are requested to connect for the next session to be handled by Dr. E.S.N. Raju, Associate Professor, Department of Computer Science Engineering from National Institute of Technology, Warangal. Thank you, sir. Thank you.
Thank you, ma'am. Thank you.
Sir, please make me as a host and leave the meeting, sir. Ambeth, sir.
Yes, ma'am.
Just making you as a host.
Oh. 1 second, ma'am. Yes. Can I leave, ma'am?
Yes, sir.
Yes.
Before that, you have to make me as a host, sir.
Oh, I will make to you host, right?
As a host.
Yes, yes. 1 second, ma'am. Make a host.
Yes, sir.
Yes.
Okay.
Thank you, ma'am.
Thank you, sir. You leave the meeting. Okay. Thank you,
Yes.
sir.
Thank you, ma'am.
Thank you, Ambeth, sir. Thank you, sir.
Thank you, ma'am. Thank you, ma'am.
என்ன ஹோஸ்டா மாத்திட்டீங்களா மேம்?
இல்ல பண்றேன் மேம். Search your name.
Senbagaraj, sir. Now you are host now.
Okay.
Make me as a host.
Sir, please make our Senthil's name as host.
Senbagaraja, sir.
Aha.
Senbagaraja, sir. Sir, are you there?
Yes, ma'am.
Sir, make me as a host, sir. I'll share some concept with you. Ma'am mistakenly make you as a host.
Yes, ma'am.
So select my name. 3 dots were there. You can select that. Make me as a host, sir.
Mobile.
If you see my name, it has even mobile or laptop. 3 dots were there, sir.
Just
In the
just
part,
a minute,
list
ma'am.
of part. Okay, sir. Dear participants, we have some healthy discussion about machine learning, deep learning. Dear participants, are you there? Anybody acknowledge me? Am I audible to you?
Yes, ma'am.
Thank you, ma'am. We have a healthy discussion about AI, ML, and deep learning. Nowadays, whatever the work we are talking about, so always we are taking using machine learning or deep learning. So Senbagar Raja sir.
Shanvaraj sir. Please make Sendal Selvi ma'am as host, sir. Please select your name.
Senbagar Raja sir.
I'm doing this.
Sir,
Okay.
click the participant, sir. Even in a mobile, click the participant, sir.
2024
Kalevani ma'am, you can mute your mic, ma'am. Kalevani ma'am. Okay, fine.
Yes,
Thank you,
ma'am.
Kalevani ma'am. Okay, fine. Till making host, I will discuss something without PPT. Anybody having the know the difference between machine learning and deep learning? Just a friendly discussion. Anybody say the difference between machine learning and deep learning? Yes, ma'am. Srinivas sir said yes, sir. Can you say the difference? I hope you posted in the chat. Any answer for the difference between machine learning and deep learning? So when I was started the research, my starting research, I don't know the meaning of ML and DL. Blindly for all the algorithm, I used the word machine learning algorithm, machine learning algorithm. Can anyone mention the difference between machine learning and deep learning? DL is subset of ML. Thank you, Meena Prakash ma'am. Deep learning uses more hidden layer to learn more complex features. Srimiti ma'am, thank you. Srinivasa said machine learning for testing small amount of data. Yes, correct. Ma'am, Smriti madam discuss about the hidden layer and everything. Is it any layers coming in a machine learning algorithm? Anybody from you? Can we add any layer, anything? Okay, fine. I'll explain myself. Okay, machine learning is for small data, deep learning for large amount of data. Machine learning won't use any layers at all. Actually, machine learning is a mathematical model. We can design the model using mathematical equations. Actually, before learning machine learning, we can very much strong in politics and statistics. So in a machine learning, we used only mathematical equation to design particular model. We won't use any diagrams. Yeah, someone said, well, Murugan sir, machine learning is neural network layer. Actually, deep learning is a neural network layer, sir. Machine learning is a mathematical model. Deep learning is a neuron-based model. In a machine learning, linear regression, we have to use linear equation. In a mathematics, we are using y equal to mx plus c. That equation we have to use. And the logistic regression, we again use the mathematical equation. So in a machine learning, explicitly we have used the mathematical model. We are not taking any neurons. The deep learning only we are talking about neurons, layers and everything. Now I'm going to discuss about with PPT the basics of deep learning model. That is how the single neuron will act. How the initially Velmurugan sir said, already said that now there is no new post in the chat box. Senbagara sir.
I'm leaving the meeting so that you can do it.
Yes, sir. You leave and join again, sir.
Okay, so far we have discussed that is we talk about neuron based model. Actually, We already discussed that is machine learning is based on
Kumar
mathematical
sir,
model.
yes, ma'am. Yes,
Okay,
ma'am.
ma'am. I'll share the screen, ma'am. I'll share the screen. Whether my screen is visible to everyone?
Yes,
ma'am.
yes, ma'am.
Yeah, thank you, thank you. So, slide. So, there is no introduction for me. I'll start myself, Sandil Selvi, professor from CSE department, SRM IST. First, before designing a neuron in a neural network, we should know about biological neuron. What are the parts available in the biological neuron? So, see the diagram. Normally, in a this is the single neuron available in our brain. Our brain consists of billion and trillions of neurons. So I have mentioned here 4 parts: dendrite, soma, axon, synapse. So here, dendrite will receive information from the external world. Okay, then the received signal will processed by soma. That processed signal transmitted through axon, and synapse will act as an interconnect between 2 neurons. So if you understand this, based on this only, we people design the neuron available in the artificial neuron. This is a biological neuron structure. We have dendrite, soma, axon, synapse. Dendrite receive a signal from the external environment. Soma process the information. Axon transmit the information. Synapse interconnect the one neuron with the another neuron. Now we compare the biological neuron with the artificial neuron. See here, the dendrite is equal to the input in the neuron. The soma is equal to the node, and axon is equal to the output, and synapse is equal to the interconnection. Based on these comparison, that is, we have to design a single neuron. I will show. This is initially the people design a single neuron that is called perceptron. So neural network design is started with perceptron. This diagram shows the single neuron structure. It has input layer and some node. The circle is called node, and output. So input, node, output. In between that, from input to the node, we are having some weights, W1, W2, W3, W4. So what is weight here? Anybody from you? Why weights are play vital role in the neurons? Any guess from you? Participants, you can post the answer in the chat. If you interacted with me, I have the energy to share my knowledge to you. Anybody?
Because different features will be extracted, ma'am, from the image.
Yeah, we have extracted the feature. Why we have to assign weight? I'm not assigning equal weight to all the inputs. I assigned W1, W2, W3, W4. Different weight. I assigned different weight. Somebody posted the weights help to learn about error data. Learn about error data. Okay, somewhat okay. Good. Thank you, sir. Anything? For strength, each feature. Very good, sir. Srinivas sir said that each feature have a separate weightage. For example, I'll explain with a real-time example. We are a teacher. We are having a student in our class. 60 students are there. Nowadays, the students have the habit of doing higher studies in abroad. They are asking the letter of recommendation. If 3 students were coming to you, one student is very regular student, very disciplined to you. Whatever activities you are giving to them, he submitted online, on time, and he is a disciplined student. Another one student is there. He never ever bother about your burden. Whatever the work you are given, he's the last person in all the work. One more person, he is not regular to the college classes. So obviously, to whom we give a LOR? The first person. because we are giving weightage, high weightage to the particular person. The same way, we extracted many features from the given input. So initially we don't know which, here I know about the student, that's why I given a weightage to the first student. As a machine, don't know about the features, which feature is very important, which feature is not an important one. So randomly it assign weightage to the features. Okay, so from the error, it correct the weightage assigned to the input. So initially, if I'm having a 4 features, 4 input, it assigned random weight. From the calculation, it decided which input feature play a vital role. So I discussed about weight. Okay, then here one activate, I mentioned the activation function. Okay, so it decide the output, what kind of output this network will give, with this neuron will give. Can you give any example for activation function? Friends?
RELU. Relu.
ReLU. Yeah, very good. This is recently used activation function. Very good. Mohammed Faisal, sir. Sigmoid. Okay. Smithy, sir. Thank you. Tan H. Very good. Okay. The next question. Normally, nowadays, the people are doing research in leaky ReLU. Very good. Nowadays, the people are doing research in 2 kind of category, either classification or prediction. Okay. Under classification, we are having a 2 kind of classification, binary classification and multi-class classification. Okay. For binary classification, which activation function is a suitable one? Dear friends, which activation function we can use for, yeah, very good, sigmoid activation function. Thank you, sir. For multi-class classification, which activation function is suitable? Anybody from you? ReLU. Sir, ReLU, we have to use in between the layers, sir, to make our model as a make it as a introduce a linearity. Yeah, very good. Kirti madam given softmax activation function. Okay. ReLU activation function used in between the layer to introduce a non-linearity in the layers, output layers. Mostly in the last layer, we have to use sigmoid and a softmax activation function. Very good. So, in a simple perceptron consists of input layer, then weight, we know what is weight, we know what is activation function, then we will discuss one example. Then one more thing, we have a word called bias. Okay, what is the role of bias? What is the role of bias? We discussed the input layer. Through the input layer, we give the input. Okay, we know the meaning of weight. Why we assign a weight? Every input has some kind of importance. Through weight, decide the importance. Activation function decide the output. Through that, we are getting the output. The output layer will decide give the output. What is bias? Any guess from your side? Error term, constant term. Why we have to include this constant term, error term? Any guess from your side? Why we introduce this constant term or error term? Anybody from you? What is the reason? For accurate result. Okay. Thank you, sir. Our aim is always to get an accurate result. But still we need something extra from you. Correct, sir? Velmurugan, sir. Thank you, sir. So why we need to add the error term or constant term to get the one answer is to get a accurate result? Anybody from you? Non-linearity, sir. Non-linearity introduced by ReLU activation function, sir. And also we I couldn't get for non-linearity, we won't use the bias term. ReLU only introduced non-linearity. Any other? Okay, I'll show what is the use of bias. Actually, while designing the perceptron, the people use, see here, I'll give a practical with the diagram, I'll give an explanation. My screen is stuck up. Yeah. See here, if you are comparing our the layer with a mathematical equation, we can write y equal to mx plus c. Okay. So if you are considering a single neuron, so we know input layer, excuse me, we know input layer, weight, output layer, sigmoid function, everything. So if you are comparing that with a mathematical equation, it is y equal to mx plus c. M is called weight, c is called bias. That is error term or constant term. See the graph here. If you are not having c term, if you are having see the left side graph, if we having no c, there is no c here. When see the lines, all the lines are passing through the origin. This origin only all the lines are passing. Okay. If you are comparing each line as a real world problem, is all the real world problem following any same path? No. Everything is different. To make our model to fit to the real world problem, we are introducing a term called error term, that is a constant term. So, if you are Google it, what is bias, n number of answer will get, you people will get. So this is my way of understanding what is bias from while I'm studying internet. One of the author will give the nice explanation like this. So without constant term, it won't suitable for the real world example. If you add that bias term to make our model to the real world, so we can add the bias term. Next. See here. So first I explain the weightage via this graph. We already discussed the weight have some importance. See here, I have a weight from, I assign a weight from 1 to 4 for W1. This is a equation I'm having. So here X for consider that 1.0 into X plus minus 0.5 into X. So here the first term is called W1, second term is called W2. Okay. So see the color difference if I'm changing the weight value. Initially, I have a weight value 1, 0.5 for W2. So if I change the weight, the steepness of the curve is changed. Okay. So through that, we know the importance of the weight. Then to know the importance of the bias, see here, if we assign the different value to the bias, the steepness of the curve changed. Now I'll give one simple example with the mathematical explanation. See here, we are having one perceptron. I have two input, X1 and X2. That is weight. I assign a different weightage. I give a more weightage to the input 1. I give a less, that is 0.75 weightage to the second input. Again, friends, one more question. What is the range of weight we have to choose? Anybody from friends? What is the range of weight we have to choose? Here I have chosen for input 1, I have chosen 1. For input 2, I have chosen 0.75. Is there any guess from your side? Is there any range to choose a weight? Yeah, 0 to 1. Thank you so much, ma'am. Thank you, Kokila ma'am and Kokila Singaram and Lakshmi ma'am. Okay, good. 0 to 1. So it will be good when you are choosing the between 0 to 1. First, here I assign the weightage, high weightage to the input 1, less weightage to the second input. And I add the term called bias term, that is errant term and constant term, to make my model fit to the real-time example. And here I'm using the activation function, that is max activation function. Actually, before initially the people were using max activation function, it means that the sum value is between 0 to comma, that is the Z is called a sum. So we have to choose the maximum value. If it is a -1 and 0, we have to choose maximum value as 0. And so by example, see here, we can define output equal to this output equal to sum into weight into input plus bias. We can convert that equation into mathematically y equal to f of x equal to summation of xi wi. Okay. See here the same problem. So C equal to W1 into X1 plus W2 into X2 plus bias term. We assign weight 1 to the first weight, 1 into 0.8. And for second one, weight is 0.75 into second input is 1.2. Our bias value is 0.5. We are getting 2.2. Okay. So we are using the max activation function. So we have to choose the maximum value. If it is less than 0, we have to choose the value as 0. If it is greater than 0, we have to choose the that C as called a combination. I mentioned C as combination. Okay, we have to take the 2.2 value. This is what a single neuron working. Okay, this is the equation for softmax and sigmoid. Okay, I'll give one example to you with the real time. Then we know how the model is working. Sudha ma'am? Ma'am? Sudha ma'am?
Yes ma'am. Yes ma'am.
Yes, join பண்ணிட்டாங்கன்னா சொல்லுங்க ma'am, நான் leave ஆயிடுறேன் ma'am.
Okay ma'am, okay.
Okay. So this is one. Initially, the people were explain the concept using the AND gate, logic gates. Okay. Now I explain the single working of neuron using one OR gate. Imagine that, yes, this calculation show you, even single neuron has these many calculation. Imagine that while we are designing CNN or RNN, any deep learning model, we put many neurons in that. So imagine that how many billions of calculation will happen inside. Okay. So here I'll explain the single neuron explanation using a single OR gate. Okay, so this is the OR gate. It has two input, A, B, and we are having one output. So everyone familiar with the OR gate truth table. So OR gate acts as like a plus. So if both inputs are 0, the output is 0. If both input are 1 or any one input is 1, we are getting the output as 1. Okay, this is the truth table. You can remember this. Here, we are having two inputs, input 1, input 2. This output is called a actual output. Actually, while talking about deep learning model, we people know actual output, predicted output. We after training or testing, we get the predicted output. Okay, here in this table, we are having the input and actual output. Okay, so now we'll move to the neuron. This small circle is a small neuron. So in this neuron, I have input 1 and input 2 and also the bias value. And also I have assigned a weightage to this input. So for input 1, first input I assign a weight as 0.2. Second one I assign a weight as 0.2. The bias value is 0.5. See here, I take the value 0, 1. I take the value 0, 1 from this table. My actual input, this is my actual output. For 0, 1, the actual output is 1. Okay. So I assigned the weight, I added the bias value. Now I'll calculate the output of that particular node. So input 1 into weight 1 plus input 2 into weight 2 plus bias into, for bias we assigned some value. So that is bias value. Okay. Then bias also, some researcher bias also assigns some weightage. It's our wish. So it is a trial and error method. So if you refer some papers, some people blindly just add the bias value. Some researcher may add weightage to that bias also. It depends. Okay. We can add the bias value directly. So here the node output value is 0.8. It will give to the activation function. Anyone give an answer why here I'm taken sigmoid activation function? Anybody from you, friends? Why here I have taken sigmoid activation function? Anybody? Why I have taken sigmoid activation function? Yes, it is a binary. Our output has 0 and 1. Actually, our resource person joined and left. Ma'am, Sudha ma'am?
Yes, it's shown a status as joining, but now.
Due to I am taking one, that's why he left. I'll
Okay,
leave from the
okay.
beginning,
You
inform
stop
him,
and
ma'am.
in the
Okay,
session.
ma'am. I make you as a host, ma'am.
Yes, yes.
Thank you, participant. Dear friends, thank you so much for your patient listening. Thank you.